Welcome to Chapter 5. In a way, Chapter 5 is where the physics actually began, because the previous chapters were really mathematics. We did not discuss any physics laws or theories, pretty much, besides units. So Chapter 5 is where the physics actually begins. And it's about forces and motion. And so the main goal is we want to learn about the connection between force and motion. So in the previous 4 chapters, we just talked about motion, but we didn't ask, why does motion happen? Why does an object accelerate? And so in this chapter, we're going to ask, how does acceleration come about? How acceleration comes about? What causes an acceleration? So chapters 5, 6, 7, and 8 are focused on Newton's laws. And Newton's laws, again, this entire course is on Newtonian mechanics. And so these are the basics of the rest of the course. And so we needed to talk about describing the motion in the previous chapters, but in order to have the mathematics background to be able to discuss Newton's laws. But now we're going to discuss physics. Okay, let's start. So by the end of this chapter, you will be able to distinguish between kinematics and dynamics. So kinematics is just, here's an acceleration, and then dynamics is what causes that acceleration. Okay, so we need to be able to tell the difference between kinematics and dynamics, understand the definition of force, identify simple free body diagrams, define the SI unit of force, the Newton, describe force as a vector. We'll see that force is a vector. Describe Newton's first law of motion. There will be 3 laws of motion. So the first law of motion. Recognize friction as an external force. So we'll have to be able to tell what's an external force and what's an internal force. What's a system? Okay, so we will do that. Define inertia. Identify inertial frames of reference. So inertial frames of reference is where Newton's laws hold. Calculate equilibrium for a system. So what is equilibrium, first of all, and how do we calculate equilibrium for a system? Distinguish between external and internal forces. Describe Newton's second law of motion. Explain the dependence of acceleration on net force and mass. So how do you calculate acceleration knowing the net force and mass? And so you have to be able to first tell what the net force is, and since force is a vector, and when you have multiple forces involved, you have to find the vector sum of all the forces, and so that's why we discussed vectors. And then explain the difference between mass and weight. They are different. Weight is actually a force and mass is not. Mass is in kilograms and force is in newtons. They have different dimensions. They are related, but they're not the same. Explain why falling objects on Earth are never truly in free fall. Describe the concept of weightlessness. Define normal and tension forces. Distinguish between real and fictitious forces. Apply Newton's laws of motion to solve problems involving a variety of forces. Explain the rules for drawing a free body diagram. So given different forces, we will draw lots of free body diagrams, and those are very important. We have to be able to draw them and also accurately draw them, and then be able to use them, and then analyze different situations, as we will see. Okay, they're simple, maybe deceivingly simple. All right, so those are the learning outcomes for chapter 5.